Welcome to ICND2 Lab 10, which describes the basic concepts behind Cisco Access Lists. For those of you using the Cisco Press exam certification guides, this video shows material that's also covered in the ICND2 books, Chapter 6. This lab has three main objectives. By watching this lab, you should be better able to configure extended IP access control lists, as well as configure one of the trickiest parts of IP extended access control lists, particularly the source and destination port numbers. You'll also understand how to see the counters that show the number of packets that have matched each statement in an access list. To reach these objectives, this scenario uses a single scenario step. In this scenario step, we'll see how to filter packets that are going from clients on the left side of the diagram to a server farm on the right-hand side of the diagram. To begin step 1, let's take a look at the network topology in the IP addressing scheme. Notice we have two routers connected by serial link, with each router having a LAN. On the left, you see we've got two PCs, PC1 and PC2, and those will be our clients in this particular lab. Over on the right, we have two PCs labeled S3 and S4, meaning server 3 and server 4, so that'll be our server farm. Now in this design, of course, we have three subnets. So we have subnet 172.16.1.0 on the left, 2.0 in the middle, and 3.0 on the right, all three using a simple /24 mask. Next, let's take a look at the criteria that we'll use to build this particular access list. For this access list, first we're going to want to permit traffic that comes specifically from client PC1 toward the web servers in subnet 172.16.3.0. Now let's examine what a packet would look like in that case. First of all, notice we're going to have an IP header in the packet, and the source IP address is going to be 172.16.1.1, which is specifically PC1, and the destination can be anybody in subnet 3. So we'll list that as shorthand with the 172.16.3.0 with the /24 mask. Next, consider what happens from a port number perspective. The client will use a port number that's bigger than 1023 and connect to the web server's well-known port of 80. So in the TCP header, we'll see some number bigger than 1023 as a source port and destination port 80. So our access list statement will need to match all four tidbits of information that you see inside that packet header and use a permit action for those packets. For the second criteria for this access list, we'll say that any clients in subnet 172.16.1 that try to connect to a telnet server in subnet 172.16.3 should also be permitted. So in this case, if you look at the packet headers, notice we'll use a shorthand of 172.16.1.0 with a /24 meaning subnet 1, and 172.16.3.0 with a /24 mask meaning subnet 3. Now the access list statement won't use that same syntax. Those are just notes for us so we can refer to this when we're choosing how to configure the access list. Now again, the port numbers, if you look at the client side of that, the port number will be dynamically allocated from some number beginning with 1024 or greater, and the destination port will use the telnet well-known port of 23. The last criteria for this access list is to deny all other traffic. So in this case, we'll use the implied deny all at the end of the access list to catch everything else and discard it. For step 1, we're going to create this access list on router R1 and then enable that access list for packets coming in R1's LAN interface. So to do that, we'll get into configuration mode as you see here and use the access list 101 command. 101's in the range of valid extended IP access lists, so we'll use that. And we'll use the action of permit because we're going to first match all the stuff that's from PC1 to the web servers over there in subnet 3. So we're going to permit that traffic. Now web traffic happens to use TCP, so we'll use a TCP keyword next, followed by the source IP address. Now in this case, since it's a specific host, we'll use the host keyword followed by 172.16.1.1, which is PC1's IP address. So there we said if it's got a TCP header and it's from PC1. Now next we can check the source port number. Now if we do a question mark here, notice there highlighted we've got the phrase or the letters GT. GT stands for greater than, and in this case we want to match packets whose source port is greater than 1023. The dynamically allocated port numbers start at 1024 and go up from there, but because the access list command can only use the greater than operator and not the greater than and equal to operator, the examples in this video always show greater than 1023 in the actual access list commands. So we type GT for greater than, and then 1023, so we said anything that's a source port greater than 1023. Next we check the destination address. Now in this case, the destination address will be 172.16.3.0 with a wildcard mask of 0.0.0.255. Now this wildcard mask means match the first three octets of this number. So any IP address that begins 172.16.3 as the destination address will match this part of the access list statement. In effect, that's subnet 3. Now at the very end, we can check the destination port number. Note the port number fields are positional. The GT1023 came after the source IP address. Now we'll plug in a check for the destination port after the destination address field. Notice here with the question mark we get tons of options here, but if we want to do something that's equal to, as you see highlighted on the screen here, equal to the port number, we type the letters EQ. So in the command we'll type EQ followed by 80, meaning equals to HTTP well-known port of 80. The second access list statement is very much like the first, with only a few variations. Now first of all, we'll use the access list 101 command again. By using the same number, we're placing this access list statement in that same access list. We'll use a permit keyword because we now want to permit all telnet traffic from the left-hand subnet to the right-hand subnet. To match these packets, we'll first plug in the TCP keyword, which means there's a TCP header, and then the source IP address. In this case, because the source IP address can be any IP address in subnet 1, we'll use an IP address of 172.16.1.0 and a wildcard mask of 0000255, again saying match the first 3 octets of this number, which of course are all IP addresses in subnet 1. Now for the source port number, which again is a positional parameter right after the source IP address, we want this to again be greater than 1023. We want to match telnet clients on the left, the source packets from the telnet clients, and those dynamically allocated port numbers will be greater than 1023. Then for the destination IP address, we plug in the same logic we had in the previous statement, 172.16.3.0, with the same wildcard mask, which matches everybody in destination subnet 3. And finally, we need to match well-known port 23, which is the telnet well-known port. Now the third criteria for this ACL is to deny all other traffic, so we'll use the implied deny all at the end of the access list, so we don't need to type in any more access list 101 commands. However, we do need to enable that access list on an interface. So we're going to first use the interface fa0/0 command to move over interface fa00, and then use the IP access group 101n command. This command enables this access list for packets coming in R1's FA0/0 interface. At this point, the ACL is enabled and filtering packets. Now that we've enabled the ACL, let's take a look and see what we've done for ourselves. First of all, not shown in the video, I've gone over to PC1 and issued a telnet over to server 3. I've also opened up a web browser over to server 3, and I've tried to ping server 3 from PC1. The ping should not work because the ping was not specifically permitted. So if we go do a show access list command, and we look at the output, notice it just lists extended access list 101 because that happens to be the only one we've configured here. And if you look at the detail in each line, you see all the matching parameters as well as the permit action for the first access list statement. And on the second line, you see all the matching parameters and the permit action for the second access list statement. So that's just a confirmation of what we just configured. Now if you look out toward the right end of the output, you see a set of parentheses with some numbers in it. This shows the number of matches on each access list statement. So in this case, we see the number of matches on the first ACL statement and the number of matches on the second ACL statement. They give you some idea of how much this particular access list is being used. Also, notice that the command output does not list the number of packets that have matched the implied deny all statement at the end of the access list. To see such counters, you need to explicitly configure a statement at the end of the access list that matched all packets and denied those. Then the output of the command would list a counter for that additional statement. Finally, just to review the configuration, if you take a look at the output of the show running config command here for a moment, first of all, there's not very much interesting until you hit the space bar 2 or 3 times. But as you get toward the end of the configuration, notice here near the bottom we see the 2 access list 101 commands, which essentially look exactly like they did when we typed them in from the command line just a few moments ago. If you scroll up a little bit or look up a little bit, you'll see interface FA0/0, and a couple lines below that, the IP access group 101n command. That's just a confirmation of the configuration that we added to the FA0/0 interface, which indeed enables the access list. In this lab, you've seen how to configure extended IP access control list. In particular, you've seen how to match both the source and destination port numbers with an IP access list statement. You've also seen how to use the show access list command to see the counters that show the number of packets that have matched each statement in an access list.